Okay, the next question was difficult, and I think a lot of students had to really have a bit of a think about that. We're told that we've got car A and car B, and that car B is on the on-ramp and is going to accelerate onto the freeway, and car A is already on the freeway. Now, important pieces of information that we're told in this question is that when we start our timer, when we start our observation, car A is at this point here and car B is at this point here. So these two are both moving at the same instant at t=0 and are moving off. That's really important because it means that the time for the motion that we're observing is the same for both car A and car B, and we can use that to then link the both of them to do our calculation. So knowing that the time is the same for A and B, we're going to try and find the distance d. We can use pieces of information about car B and the fact that we know that car B is going to travel 400 metres, and we also know that it has to accelerate up to 80 kilometres per hour. So, and it started at rest, we can use our SUVAT formulas to do a calculation. So for car B, I've listed what I know. 400 metres, u=0, velocity is 80. Now remember, this is in metres, this is in kilometres per hour. We have to change everything to the same. So 80 divided by 3.6 gives us 22.2 metres per second. I don't really need to know the acceleration, though you could use that to do a calculation. What I want to know is the time. So I'm going to use the fact that speed over time, and we use this when we actually derive the SUVAT formulas. So the speed over the distance over the time, average speed is equal to distance over time, and the average is going to be the sum of 2 divided by 2. Remember, when you average two numbers, you add them together and divide by 2. So using that, we rearrange for t, and we get that. Plugging in our numbers, we find we've got 36 seconds. Now that we know it's 36 seconds, we know that that means it's 36 seconds for both car B and car A. We know what speed car A is travelling at, and because it's a constant speed, we can then just use speed equals distance over time, and then do our calculation for rearranging that, and that gives us 800 metres. Now, quite a few people did these calculations but didn't convert, and because of the way the problem worked, because you didn't convert, you used the time and then you resubmitted it in, people still did get the same answer. My only concern with that is that if you were asked a similar but different question, i.e. finding the time, you would get the question wrong. And as we are marked for working, because this is a 3-mark question, you need to be very wary that you had things correct all the way through. You may have been penalised for making that mistake there, even though in the end the answer comes out the same. Okay, last part of this question was to then think about what the speed time graph would look like. First thing we need to know is we know that both of these situations result at time, it starts at time =0, so this option A is not going to be an option because these are starting at different times. The other thing that we know is we know that the car is accelerating to get to 80 kilometres per hour, so car B, and then it's going to flatten off because it needs to merge in. So we also know that D is not an option. Often with the multiple choices, it's worthwhile trying to remove options, and then you look at what you're left. Now, the last most important piece of information is the fact that from when the lights change to green, t=0 to the car merges, ty. So again, going back to our question, we're told that at this point y, that's when our car B reaches its maximum speed of 80 kilometres per hour, and we use that to calculate the time over that distance. So this means that the only option for this graph must be when car B reaches 80 kilometres per hour at yt, which is option C.